This video is for lesson 4.4 and on pages 153 to 155. I'm hoping I can go through this lesson pretty quick because this is the one lesson I've chosen to focus on when I'm with you one-on-one in your building. So as far as my one sheet goes, I added this little visual reminder that scientific notation is always in the format of a number times 10 to the power, and remembering that that first number has to be greater than or equal to 1, but then also less than 10. And then for a positive exponent, we're going to be talking about really large numbers. When I met with you, we talked about terabytes and gigabytes, 1 times 10 to the 9th and 1 times 10 to the 12th. And we also talked about negative numbers being really small numbers. So a nanobyte, 1 times 10 to the negative 9th, and a pico, 1 times 10 to the negative 12th. So definitely a way to relate what we're learning with some information about computers and technology and nanotechnology especially. So I'm excited to see if any of you decide to do a little research on that and see what's coming down the way for some nanotechnology. As far as, again, my one sheet goes, in the upper corner there, I just added the notes that I told you for scientific notation. Section 4.4 is pretty quick, just making sure you know how to write numbers in scientific notation and then take scientific notation back to standard form. So we'll get started on page 153. At the bottom there, example 1 says to write or do the problems, express the number in standard form. So for 1a, it's 4 times 10 to the second power, so that's just 400. And for 1b, that is 5.94 times 10 to the 7th. So 2 of those decimal places will be taken up by moving it over to the right of 4, but then we'd have to add additional 1, 2, 3, 4, 5 zeros. And so what we have here is 594,000,000. And if we put our commas in, we get 59,400,000. Okay, you can't really see that. For 1c, we have 1.3 times 10 to the negative 3. And if we move that back 3 spaces, 1, 2, 3, we have to fill in 2 0 placeholders there and then put the 1, 3. So that's 0.0013. For example 2 on page 154, you have some examples of expressing each number in scientific notation. So for 2a, it says 900, and write that in scientific notation. So 900 is in standard form. Scientific notation would be 9 times 10 squared. For 2b, it's 18,900. And again, we're looking to place the decimal somewhere so that we get a number greater than or equal to 1, but less than 10. So this becomes 1.89 times 10 to the 4th power. And then for 2c, it's 0.000064. And so again, we're looking for a place to put that decimal. 6.4 is greater than or equal to 1 and less than 10. And I have to move that decimal back 5 spaces to the left, so it's going to be times 10 to the negative 5th power. All right, for the next example, example 3, it's again taking each number from standard form to scientific notation. But if you have a number that is a large number, for example, 3,465,582, you're not going to want to include all of those digits when you're writing it in scientific notation. It's okay to estimate. So for 3a, when it says 3,612,500 centimeters, we could just write that as 4 times 10 to the 6th. Of course, you could do 3.6 times 10 to the 5th power, if you wanted to keep 2 of the decimal places, not fifth power, I'm sorry, sixth power. But this is not the same example there, by the way. That was just showing you before we got started. So 3b says 0.0000000251. And so, again, you could put 2.5, or you could put 3. And then we're going to move it back 1, 2, 3, 4, 5, 6, 7. So times 10 to the negative 7th, or times 10 to the negative 7th. Again, we're estimating here, so don't worry too much if you're off on these, as long as you're somewhere within that range. And on 3C, we have 4.215 times 10 to the negative 3, and we could just estimate that as 4 times 10 to the negative 3. That is example 3. Example 4 has you looking at some story problems. So at the bottom of page 154, it says a dime is about 5.875 times 10 to the negative 3 feet in diameter. Is it more appropriate to report the diameter of a dime as a measurement in feet or inches? And explain your answer. Well, think about a dime, and probably thinking that a dime's diameter is not too large, so probably it's more appropriate to say 7.05 times 10 to the negative 1 power. A little bit more meaningful than measuring in feet with a measurement that's so small. Finally, on example 5, it asks to do a story problem and compare some numbers written in scientific notation. So approximately 1.372 times 10 to the 7th square kilometers of Antarctica, and then there's about 1.834 times 10 to the 6th square kilometers in Greenland, and they're covered it by an ice cap. Which land mass has a greater area covered by ice? Well, in this case, 10 to the 7th power is bigger than 10 to the 6th power, so Antarctica is going to have the greater coverage. So hopefully those get you started on lesson 4.4, and you're able to be successful in the homework and the self-check quiz. It's pretty straightforward. Plus, we've also done a little work one-on-one when I'm with you in class. So do well.